the second case. This is a beam which both sides have a force of 160 kilonewton. So what's the force inside this beam?
Same.
Same. Why is it same? This is the correct answer. I mean, how many of you confused about this answer before you listen to before?
I'm very confused.
Yes, sir. Right. Okay. Never mind. I know this is a very confusing part, but apparently not many of you are confusing about this. I'm very happy about this. Okay. So in fact, every time when we look at a force analysis of a particular object, we will tend to delete some of the necessary information. Okay. Actually, when you look at this one, you notice that there's one force, 160 Newton applied at one end. But how about the other end? How about the wall? Since it is attached to the wall, there is possibly a force acting on the opposite direction of the same magnitude. Okay? So in this case, how do we know that the force from the wall to the object is exactly 160 kilonewton in the opposite direction? How do we know that? Yes, it's according to the rule of static equilibrium. Okay? So it's because the resultant force on this object from both directions maintains this object static equilibrium. So that the force at this side cancels out with this side. So that's why it does not move at all. Okay? So that's why there is a force of 160 kilonewton at the opposite direction at same magnitude. Okay? This is a way we observe its status and we decide what are the forces inside. Okay? This will be the fundamental skill for you to solve the questions later. So maybe you are not very impressed by this question. How about the next? Can you see it clearly? Okay. Now, so this beam is pushed by these two forces, both of 120 kilonewton, to the second beam, which is of larger diameter. The diameters are shown here. Okay. So here is another force pulling this rod with a 160 kilonewton force. Now the question is, I want you to tell me what is the force within, or what is the force within this rod, and what is the force within this rod.
160.
Tell me the first answer. What's the force within this rod?
160.
160. Why is 160? Okay, let's analyze them one by one. This is the standard procedure for analyzing the forces. Okay, look at the first part, AB. What are the forces experienced by this AB? First, definitely, most obvious one is the 160 kilonewton, correct? Then, 120 kilonewton from both sides. Are there any forces that acting on this part? Any other forces? Any other possible forces?
Yes.
Yes. Is this force act by the second member to this force? What is the magnitude? Currently we don't know. Okay. This is from the member BC. Okay. FB. We call it FB. So these are the four types of forces experiencing. So how do we know this FB? This is again, we link back to the static equilibrium. The resultant force should equals to 0. So that's why the force, horizontal force at this side equals or plus the horizontal force at this side equals to this two horizontal force summation. Okay. So 160 plus this FB equals to 240. Okay, so you know what is the FB here. Okay, but the question is, what is the force experienced by this member inside this member? What is the force experienced by it? Any idea? 160, correct? Still think back to the question. Because here, later we will find that this 240 minus this 160, which gives us 80, correct? 80. So, the force experienced by this one is, how we call it? Actually, these three forces, they sum up together, give us another 160 at the other direction, correct? These three forces at this side. 120 plus 120 minus this 80 give us another 160 at this side. So actually this goes back to the same first case, which the beam is subjected to two forces of 160 at both directions. Okay. So this is what we call the force analysis of the first one. The second one will be the same thing. Second one, because the second member has given the first member a force of 80 kilonewton at this side, correct? So this 80 kilonewton is the force given by this to this. So as the reaction, this member also gives a force of 80 of the other direction to this member. So actually for this BC, member BC, it has a force from member AB of 80 kilonewton. What are the other forces that it's experiencing for the second part? Other possible forces.
From the wall reaction.
The wall gives it a force, correct? So in order to maintain the static equilibrium, this force comes from member, the first part, and this force comes from the wall. They will just cancel out each other so that they can maintain static equilibrium. So in the end, the force comes from the wall. We immediately know is 80 of the leftwards direction. Okay. So this is the way we do force analysis. So just now, as you may notice, whenever I ask you about this, what are the possible forces that may have in this member, may experience by this member? Okay. So how do you know what are the possible forces? Do you know how to get the possible forces? By instinct, definitely. Yeah. What is the instinct in terms of words? Is whenever you analyze force, you find all the possible forces by looking at its contacting point, correct? Because here, you look at a wall, you know that the wall contacts with this one. So the wall is a possible source of force. The wall might give this member a force. So this is a way of us to analyze the force. The first thing, when we analyze a force, the first step we need to take is to look at different members, okay, different objects inside this whole system. For this one, there are two objects, two systems. Okay. The second thing, what did you do just now, is to do force analysis, to draw free body diagram of each individual, okay, and to analyze all the possible forces on each individual. Okay. So here, just now you analyze the force by looking around to say what are the possible, what are the contacting points. Then you find what are the possible forces. In the end, the third step, the last step, is to use these very basic two equations. The summation of forces equals to 0 and the summation of moment equals to 0. Okay. So everything inside this static equilibrium force analysis, just use these three steps to do it. That's the standard operating procedure. As your experience accumulates, later you will know some shortcuts. But for this stage, you just stick with this standard operating procedure. Okay? Now, a little bit tricky one. Just now we have only touched the forces. Okay? Now we're going to touch a little bit on the moment. Okay? For this one, A and B, remember AC and BC are two rods. Okay? The C, A, B, they are all revert joints. Not revert joint, they are all joints which allows free rotation. Okay? So if they are joined like this currently, if I apply a force F horizontally in this direction, what are the direction of forces